Let's zoom in a little bit more closely on this oscilloscope. I'm still displaying a trace which has a frequency of 1000 cycles per second, or 1 kilohertz, and is varying between plus 5 volts and minus 5 volts. And I can actually see that on this trace. At the moment, I can actually just read on the screen that the vertical scale is 2 volts per centimetre, or 2 volts per division. And so I currently have it set so 0 is across the centre of the screen. There's 0, it's going up 1, 2, 2.5 centimetres, which is 2.5 times 2 is 5 volts. Or going negative, minus 2, minus 4, minus 5 volts. And so I can adjust the scale so I can read the voltage. The time scale I currently have it set on is 250 microseconds per division. Now I can see a full cycle of this. The voltage is crossing up through 0, there to there to there, making a full cycle in 1, 2, 3, 4 centimetres. 4 centimetres, or 4 divisions, times 250 microseconds. 4 times 250 is 1,000. 1,000 microseconds is a millisecond, which is 1, and so that is 1,000 cycles per second, or 1 kilohertz. Now how do I adjust these things? Well, all these complicated controls on the front, basically there's my input for channel 1, which is the only thing I'm looking at the moment, and it says vertical there, there's your voltage adjustments there. If I alter the voltage, if I go to 5 volts per centimetre, I'm now going between plus 1 centimetre and minus 1 centimetre, between plus 5 volts and minus 5 volts. There is 2 volts per centimetre. If I go down to 1 volt per centimetre, I've gone a little bit too far because the graph is now going off scale. And if I go any more sensitive than that, it'll go even more off scale. So the first thing you have to do when adjusting the voltage is basically adjust the voltage control so that you see a full cycle of the trace filling as much of the screen as possible. Now what about time? The controls that control the time base along here, or the horizontal, are these controls here. They control how fast the graph sweeps across. At the moment I've got it at 250 microseconds per division. If I make it 100 microseconds per division, I can now see, if I've now zoomed out, so a full cycle is crossing downwards going there, 1, 2, 3, 4, 5, half a cycle, 6, 7, 8, 9, 10. 10 times 100 is 1,000 microseconds is the full cycle. Or I can go the other way. There we have 500 microseconds per centimetre. And now I'm seeing a full cycle is 2 centimetres. 2 times 500 is 1,000. And so 1 thousandths per second is there. And so again, the thing to do with adjusting your time control is to not go so far out that you're missing a full cycle of the motion, but not go so far the other way so that you're beginning to see too many cycles to make sense of it. So again, we need to adjust our time base to give us a reasonable graph across the screen. Now another thing I can do with the adjustment is there's this button down here. That tells me where 0 is. At the moment I've set 0 across the middle. As I adjust that, I can move the 0 point up and down. I can even move the 0 all the way down to the bottom of the screen if I wish. For this particular graph, it makes the most sense to have 0 across the centre of the screen. I'll set it back to there and let it redraw itself. There we have 0 across the centre of the screen. I can also adjust in the horizontal. I can move the graph backwards and forwards. And this may be of use if I want to adjust things, so if I want to measure the time it takes for a full cycle, if I want to set the graph to start exactly at the beginning there, instead of crossing in the middle. And so you can adjust the horizontal position. We're showing our trigger point. If you watch the little indicator there, as I move, I can move that backwards and forwards, and I've got that centred there. So our trigger point is right in the middle there at the origin when I have that there and that across that axis.